Good morning, everyone. Thanks so much for joining the Western Canada RPA user group. Today, we've got a really special guest, I should say. We've got Reveal Group, which is an innovation company that specializes in transforming businesses through cutting edge technology and strategic solutions. They've got a savvy team of experts who are dedicated to intelligent automation, among other skill sets, naturally. So as part of this, I'd like to introduce Josh, who is a partner at Reveal Group. Josh has a long history of innovation. He's an influencer. He's a videographer. He does photography and a whole bunch of really innovative tech stuff, which is really interesting. There's always something neat that he's working on. If you're wondering how to innovate, Josh is your guy. And so I'm super happy to have him and all the other people that are joining us present on this topic. So yeah, I look forward to hearing the presentation, Josh.
It's just Doug and Anna and Aiden.
Great. Okay, Doug, Anna, and Aiden. Great. All right. I think we've got the technology set up now.
Awesome.
Perfect.
Cool. Awesome. Well, I appreciate everybody joining again. We will show a few different things as we go throughout this. I'll give you a little idea of the background and introduce themselves here. But I've had a lot of conversations over the last year or so where companies have looked at deploying a traditional IDP solution, a traditional NLP solution, and have kind of pushed back on isn't OpenAI going to take over the world? Why would I put something in place today? Because, Gen AI is going to do all of those things in the near term future. So maybe we put that on pause. And you kind of have to go through that conversation of what the realities are. If you're trying to do invoice processing, let's put an OCR, ICR in place. Let's not wait for the Gen AI magic necessarily for that. But recently I had a customer comment on one of the things that we helped to deliver and said, oh, well, no, what you did was you paired the old AI with the new AI. Really kind of like that way of framing things. So our conversation today is really going to be showing a few different ways that we can do that, to pair that old AI with the new Gen AI types of solutions. We'll show a couple different things. First, we'll take a look at comms mining. And if anybody's ever had to do a project where you're training machine learning, you know that there is a lot of time and energy that your subject matter experts have to put into that to tag up content, whether that's for NLP projects, IDP projects, you name it. What we can do now with generative pre-training and comms mining is pretty cool. Probably give us an idea of where some of these other technologies will start to go. And then we'll take a look at two different ways of doing a generative AI enhanced extraction, one with comms mining around emails, the other with generative extraction around documents. And so before we dive into it, we'll do a little roundtable introduction. Jesse, appreciate the intro for me. So Aaron, why don't I start with you?
Hey, everyone. My name's Aaron Phillips. I'm a senior manager with Reveal Group, operating out of our Toronto office. I primarily oversee UiPath deliveries, but I do dabble in some other technologies. And I'm really excited to speak with everyone today about communications mining, a relatively recent acquisition on that front. Thanks, Josh. I'll throw it over to Doug.
Hi. So yeah, Doug Merrill, senior manager in our New York office here. Dabbling in a whole variety of processes from discovery all the way to production here. And we've been doing much more with the IDP and Gen AI integration. So we'll be touching on that subject when we get there.
Hey everyone, I'm Aiden. I'm also here at Reveal Group. I'm a senior consultant, and I originally started in the Blue Prism space and sort of eventually made my way over to the UiPath space. And I've recently been involved in projects like document understanding and now a lot of communications mining. So I'll be speaking a little bit about that today. Thanks. I'll throw it over to Anna.
Hey, my name is Anna. I'm based in the New York office. I primarily work with healthcare and also with our Gen AI projects.
Awesome. Great. And again, you'll see the disclaimer down at the bottom. We will be showing some examples on here. Just so you know, none of this is real customer information. It's either pulled from publicly available sources or it's things that we've had to mock up for demo purposes like this. So as I was mentioning at the beginning, this idea of, is it old AI versus new AI? And I think what we'll be able to show you today is really combining the two technologies, the two approaches to AI machine learning really can deliver far superior results. Our themes that we'll go through today be a fairly cost-effective way to get you into much more unstructured data sources that were previously much more difficult to get into. We'll cover the Gen AI pre-training. We'll cover Gen AI extraction in a couple different ways, one on emails, one on documents. And again, this idea of how do we tap into unstructured data, whether it's in emails or in documents. A couple things, if you don't kind of have the background on working with traditional IDP tools or traditional NLP tools versus our new Gen AI overlords over here, Mr. Bob Ross. And a little difference there is historically your traditional IDP, NLP tools out there require a heck of a lot of human training, a human intervention, human markup. And we'll see how we can improve that today. But it needs that before they start producing results for you. And the fascinating part on the flip side, when we think about Gen AI, is it requires very little training, or in most cases, you can't really train it. You can maybe lean it a particular direction, but generally not building your models from scratch. Or if you are, we're talking a whole different ballgame on costs. Generally, your Gen AI tools in comparison tend to be fairly inexpensive, and they can be additive, and we'll cover that in a little more, versus your traditional big bang holistic end-to-end solutions. But those end-to-end solutions provide a lot of capabilities that you won't find in just your Gen AI widgets themselves. Obviously, with your historic, IDP and NLP tools, they can be highly tunable, highly trainable, versus, again, prompting for things, hoping you're getting the right answers back. But with Gen AI having kind of that pre-training already out there, there's some other things that will become a little more obvious. But one of the things that we'll probably get to just when we get to the QA is that there is a big challenge when we try and test out and vet out these approaches. One is that if you think about historical document processing, what it reads on a page is going to be the exact text on the page. It's either right or wrong. It's trying to pull that exact phrasing off of the page. Whereas we add a Gen AI version of an extraction, now we have to deal with something that can go and reword things. It can go and interpret what it has on the page. So when you try and test and say, hey, was this the exact right answer? Now you need a little more human verification that's going on, because it's not necessarily a one-to-one answer to what's on the page, but it may be factually correct on what it's extracted. So we've had to build test rigs and things to work around those challenges. But let's start to get into some solutioning. If anybody is brand new to this and doesn't know, I mentioned that we're tapping into more unstructured data types. Structured data types are going to be things where your fields are always going to be the same. It's maybe a form that you've built yourself, or a form that is very static. We can look at positional data and we can extract information off of that. Semi-structured starts to get into things like, say, invoices are a great example. We always know that there's going to be similar information on an invoice. We know there's going to be header information. We know there's going to be lines. We know there's going to be line totals. But the exact position of that information about in the header may be different invoice to invoice. And the number of lines in the tables within the invoice would vary. So in that case, we know generally what's going to be on there, generally where it should be, but it's never going to be the exact same time to time. And then we move all the way to what we'll talk about today is unstructured data. We'll look at that first in the form of emails, then we'll look at that in the form of documents, but these are going to be more long-form prose where the data isn't necessarily in an exact position. It's going to change document by document or free-form email to free-form email. We've done some interesting things to make some of these unstructured, at least in the document space, feel a bit more semi-structured, and tackled that in a slightly novel way, but I'll let you judge for yourself on that one. But hopefully that gives you an idea of we're trying to go for those things on the right-hand side that were historically quite difficult to get into. The one other thing we'll set for context is comms mining. For anybody that's not already familiar with that, maybe I'll pass it over to Aaron to give you an intro to what comms mining is.
Communications mining is a recent acquisition by UiPath. And really, when we think about communications mining and what kind of problems it solves, I like to give the scenario of, how many times have you been assessing a process for automation and realized, oh, it's actually triggered from an incoming email. And, we really can't automate the end-to-end because we need a human to read the email, understand the intent behind it, extract some key data points, and then send that over to our bot via some kind of structured web form. Communication mining helps us by structuring unstructured data. And I like to kind of explain it in terms of inputs and outputs, and then the types of solutions we can build with those outputs. So Josh mentioned emails as the poster child use case for communications mining, but really any unstructured communications data will work. I'm talking chat logs, Google reviews, social media feeds, anywhere where there's structured chat data. And tending on the shorter form, Communications mining helps us by automatically classifying the intent or topic of the communication, extracting specific data fields from that, and then providing a prediction about the sentiment expressed in an email, right? Is this a happy or a upset customer, right? And we can kind of combine these different outputs. So the output of a classification we call a label, the specific data we're extracting we call general fields, and then sentiment as our kind of third key output there. And so it gets quite powerful when you mix and match these different outputs to solve different business problems. The first one being our communications analytics, right? Understanding to a very detailed degree, hey, what actually lives in this inbox? If you have a team working out of a large shared mailbox, it can be difficult to see the different kinds of requests in detail that live inside that mailbox. And so, it's a very, very powerful discovery tool to just come in and see, hey, what are our top request types? Can we now go in and do some process assessment to see if these are good automation use cases? And so not only can we look at kind of our top categories, but we can combine labels to form some pretty powerful analytics, right? Hey, if we train a model to identify complaints or maybe follow-up emails, we can then see, hey, what are our top categories where our customers are following up with us to get responses because we're not answering in time? Or which process is generating the most number of complaints? So some pretty powerful analytics there. But what gets really exciting is where we actually start to trigger automations based off of those classification results. And so kind of the great example I like to use is something like a password reset, right? If someone emails in and they've provided enough information, right, within the email to identify them as a user, we can actually maybe go in and automate the password reset response, whether that's actually resetting the password for them or directing them to some kind of a self-serve option, being able to not only identify the request within an email or communication, and then extract all the relevant data to process that request, creates some pretty powerful automation use cases. Lastly, when we combine sentiment, right, we can really, really make this powerful by doing things like prioritizing our upset customers, right, jumping them to the top of the queue and making sure that they get a response quickly. So with that kind of introduction, I want to take a quick look at how communications mining have used some large language model enhancements to improve the classification, training, and extraction. So with that, maybe I'll throw it to Aiden to talk a little bit about some of the recent updates to the communications mining platform.
Thanks, Aaron. Yeah, let's dive into something called generative pre-training and see how generative AI is enhancing communications mining. Go to the next slide here. So as we know, in most machine learning training contexts, the bulk training component takes a significant amount of time to complete. Typically humans would need to classify a large amount of communication to give ML model a solid foundation before it can start making these reliable predictions. And this is really where generative AI changes the game with something called assisted labeling, which dramatically speeds up the training process. And what you're seeing there is like an automatically generated prediction for each label with sufficient context. But the beauty of this is generative AI allows us to give the model no pre-training. It can even suggest new categories. So you might ask yourself, well, how does the model give these sort of predictions if you haven't given it any input at this point? You can give the taxonomy, or you can create your categories, and you can give them natural language description. And this is what will really drive these initial predictions. So assisted labeling still needs supervised learning, right? A user needs to come in, accept and reject these, but it accelerates the most time-consuming part of model training by offering better predictions with very few pinned examples. Because traditionally, a human would have to go in and make all those little sort of suggestions saying like, here's 100 cases where I've seen password reset. And then the model will be like, I'm pretty confident when a new one comes in, I know what I'm looking at. But just by giving it a label name and a description, the model can start making these predictions really early on. So in essence, this approach combines the strengths of generative AI, LLMs, and human oversight, which is a pretty cool combination in my opinion. So just to wrap up this slide, Gen AI has the capability that allows us to quickly train our ML models, enabling projects to get off the ground much more efficiently.
And I think that hits on a key point that we've been seeing over the past, let's call it a year and a half, couple of years here, when we talk about the large language model approach on things. I mean, the first use cases we got into with large language models were actually using GPT-3 to generate testing content for us. You mentioned IT service tickets. That was one of the earlier use cases we were trying to solve, and we just couldn't get enough IT service tickets out of Freshdesk. So we had Gen AI, actually GPT-3, generate those for us, so we could train up other types of IDP or natural language processing capabilities. Your point of, this is very additive to what the humans would otherwise doing. I mean, nobody wants to sit there and have to manually do the drudgery of, tagging up every document and manually annotating things. Auto-populate that for you, and now you've got eyes on glasses, just more verifying that it was correct in its predictions, or adding in where you think, here's some additional tags we should start to put in. So, Aaron, you want to get into the how we then flip around and use comms binding for generative extraction?
We'll stick with Aiden for this one. I'll pick it up at the end and talk a little bit about a real life example with one of our customers.
Cool.
Awesome. Yep. I'm sure everyone's already read the title here, and you could sort of start making your own guesses on what this is going to be about. But, before I talk about generative extraction, I really want to talk about, where it comes from, like what the problem actually is. So if you could hit us to the next slide there, Josh. As we all know, a single email often contains multiple complex requests with various data points. It's never as straightforward as my name is Aiden, I want to reset my password, here's all my identifiers. It's never that simple, right? Originally, when extracting this data, we lacked the understanding of the relationships between the different requests and the associated data points we required to process them. This is where generative extraction, also known as GenX, comes into play. It's an innovative feature from UiPath Communications Mining that leverages generative AI to comprehend the intricate relationships between multiple requests and their data points. So as we can see on screen here, we've got an example that we've sort of mocked up and consider this, right? It says, please reinstate Aiden's coverage starting July 31st. Also reinstate his spouse Tiffany's coverage on August 1st. The couple recently got married, so the spouse wishes to update her name. We've clearly got two different intent in this email with a variety of data points. There's actually quite a few on the screen. So, previously extracting all the critical data points was feasible, but assigning them in an intelligent way to enable downstream automation was relatively challenging. So that's where GenX really comes in and streamlines everything. The tool intelligently assigns data points to intent, or labels as they're called in the platform. And you can see this in our example. If we just look to the right of the screen, the model has sort of classified the two label intent, the one being a reinstatement, the other one being a name change. So we can see that there are actually two reinstatements, and they've both been grouped. The PMIDs, the effective dates, first name, last name, has been grouped into sort of row 1 and row 2. So downstream, the automation could process these individually because they've been grouped. GenX really improves data processing precision by automatically recognizing these multiple data points and their relationships in a single communication. It streamlines efficiency by accurately converting these raw data points into grouped inputs, ensuring seamless processing of compound email requests. And I really feel that's the point that everyone should focus on, is that usually when an email is a single intent, it's pretty easy to automate, right? But when it becomes a compound request, it becomes harder to understand the relationship between all the data points. And as you can imagine, this capability is invaluable in real life projects.
Great. Thanks, Aiden. So the quick background to this was our customer was a group benefits provider in North America focused on health and dental benefits. And really, they were experiencing a huge increase in customer emails year over year, nearly 20% across different departments. And so if you've ever dealt with teams that work out of shared mailboxes, you'd know that there's a few different challenges that come along with working with those teams, right? It tends to be very opaque. It's hard to see who's working on what, how complex or how long should each kind of individual request take, right? These requests tend to be very unstructured. People are asking the same thing in 8 different ways, 2 different date formats, right? It's kind of all over the place. And lastly, the feedback that we were getting is, hey, these requests are actually getting more and more complex. And so despite their best effort to point people towards self-serve options, self-serve options tend to only take away kind of the most simple requests. And so these emails are getting longer, more compound, like Aiden was showing us, and their existing efforts to categorize emails proved to be fairly inefficient, right? It used these high-level categories, and it relied on users to actually select the category when submitting their question. And so the solution in this case was to streamline email management with communications mining and drive some valuable insight and process efficiency for their primary contact center. And so when getting started with communications mining, this customer started with a proof of concept project that spanned over 4 weeks. And in this proof of concept, we took over 100,000 emails, which is a lot of emails. You don't need nearly that many to get started, but with most AI-based solutions, the more data, the merrier. We worked with subject matter experts from the business. So these aren't kind of technical teams that were involved. It was actually their quality control team from the contact center who created all the different categories of emails and then proceeded to train the machine learning model on how to categorize those emails and extract some key data fields. And so in just 4 weeks, we were able to categorize over 93% of emails into 43 different label categories. And when these categories show up, you can then start to perform some discovery work on those emails to understand what business processes actually get triggered from these emails. And so from that discovery effort, we were able to identify 9 automation use cases, and one of which we actually built a demonstration for. And these 9 use cases were over 12 FTE of effort, about 23% of the total administrative effort of handling emails. And so I'll talk quickly about our proof of concept use case and then touch a little bit on the production implementation that came next. But when it came to our proof of concept use case, we were looking at insurance eligibility, right? Hey, am I covered for this kind of a procedure? And we kept it relatively simple at first, and we focused on massage therapy, right? And so towards the end of the benefit year, a lot of folks were emailing into the contact center, wondering, hey, how many dollars of massage benefit do I have left? Hey, what's my copay if I were to go get a massage? And we were able to build an automation use case that used communications mining to correctly classify the type of request, extract some key data like their account number, their user ID, their ID, and actually go into their policy management system, look up the details of that coverage, and respond automatically to the member with those details. So it was a pretty powerful use case, and it was essential in securing executive buy-in and sponsorship for the preceding production implementation. And so again, maybe just a quick teaser for the production implementation. We found some really, really strong use cases, including things like identity verification. So if you've ever worked in a call center, you might have experienced this, but people never email in with the same email that they signed up for or have registered on their accounts, right? They'll use their 7th Gmail account to email you. And so often agents were actually just responding back to these inquiries saying, hey, could you please provide us some more information to prove that you are who you say you are? And we were able to use communications mining to identify, hey, was enough PII provided by the requester to process the request, or do we need to automatically reply to them, letting them know that they need to provide us additional information? And so that ended up cutting SLAs in half for a number of these requests as we were able to eliminate that first touch. We were also able to automate some simple transactional requests like password resets, as well as some more complicated ones around claim disputes.
Thanks, Aaron. And it's funny, you mentioned the auto reply side of things. We just delivered a process in the invoice processing space where if a vendor emails in an invoice and it's missing information, after we do extraction with Abby, we can automatically reply to that person that sent the invoice or look up a different contact that's on the vendor master record and let them know, hey, we're not going to be able to process them because you didn't put the PO number, for example, on the invoice, and that's required. It starts to change user behavior. That we find that the PO number was in the body of the email that sent the invoice, but wasn't actually on the invoice itself, which sort of things often would have had to have additional natural language processing capabilities. So switching gears here, well, kind of switching gears, we're still talking about generative extraction, but now instead of looking at emails, we're looking at documents, using a completely different set of technologies to do this. And By the way, I should mention one other thing on what Aaron and Aiden were covering. What's really interesting while we were talking about UiPath comms mining, UiPath comms mining can actually trigger automations in other systems as well. So those automations that Aaron was talking about don't have to necessarily be a UiPath automation. You have a different BPM tool, you have some other sort of workflow tool that needs to kick off. Those can be fired off via APIs front-loaded by UiPath comms mining. Introducing kind of our new use case here. So we're working with an organization that needed to extract a massive amount of information out of lease documents. There's a new regulation that went into place in the US starting last year, where privately held organizations needed to start reporting information about their open leases that are over a year. They needed to put them on the balance sheet as a liability. And that was a huge burden for organizations, particularly if you have a lot of properties. But the regulation didn't just stop at properties. If you rent equipment, heavy equipment, you're renting cars for your company, you're renting PCs for your offices, all of those need to start being reported on the balance sheet. That becomes a huge paperwork burden for organizations. In this particular case, they needed to extract over 100 different fields from documents that could be 60 plus pages long, which turns into a massive unstructured problem for us. So to give you an idea of what kind of the big bad of what we have to be able to extract from is, again, if you take a picture a lease because you rent an apartment or something where you purchased to have a mortgage on a home, very similar sort of things that are going on here. You've seen these just massive bundles of information on these documents, but at least you have in your mind kind of what we're trying to extract is 100 fields out of these massive, dense, prose-heavy documents. And so we found some interesting ways to go and do that. It took a lot of time and energy in vetting out of quite a few different technologies. I think in the end, there were 9 or 10 different technologies, and then further combos of those that we ended up vetting across the field to be able to figure out how to do this as accurately as possible and with full functionality that will satisfy real end users actually wanting to use this tool.
All right. Thanks, Josh, for setting the stage there. So as Josh just went through, the question became, how do we address this business challenge? And so in order to solve it, we decided to run parallel tests on competitive solutions. As you can see on this slide, we've outlined a set of criteria for our testing phase, ensuring that they were truly beneficial for business users. I wanted to highlight 4 key criteria, starting with accuracy, which we have there at the top. This measures how precisely each solution could extract those necessary data points without errors expressed as a percentage. Next, we had manual review. A native manual review station was essential for providing that additional layer of quality control along with flexibility and adaptability in our workflow. And then insights from those manual reviews would then help us continuously improve those automated systems and would enhance the overall effectiveness of the solutions. Lastly, we needed a solution that could highlight relevant sections in the documents to streamline the review process, which would become especially important with those longer documents that could span up to 60 pages, as Josh just called out. So this targeted approach would save time and ensure reviewers could focus on the most critical parts of the document. Additionally, identifying and highlighting those low confidence fields would allow us to flag uncertain areas for extra scrutiny, thus helping correct potential errors and again, maintain that high data quality. Overall, these criteria anchored our testing process and ultimately led us to that multi-tool approach. I will now go through each of those solutions and explain why we decided to combine them. So starting off with Abby, as you can see here, which is an IDP tool that excels at reading and extracting data from documents. As you can see, Abby met almost all of the criteria, featuring that critical native manual review station and that powerful segmentation tool that efficiently extracted document segments. However, it fell short in terms of accuracy and extracting fields without prior training. The lack of a prompt engineering component led to less accurate field classification. And although Abby is improving its NLP capabilities, it still requires significant training as it is not natively an NLP tool.
Important point there as well is in not every one of these points is equally weighted as well. So I give you a visual on there. But as Otto said, once we have a significant amount of training marked up, we can get better with that field level extraction. But with a Gen AI approach, there's no markup that's necessarily going on for us to be out of the box efficient with that. So important differentiator on there. But Abby then serves as, a foundational program for us to be able to, fill the one gap. So
Yeah, that's a great call, Josh. So as you can see, simultaneously, we were exploring OpenAI's GPT-4 vision model. This is an LLM that analyzes specifically PNG images and provides textual responses by combining NLP and visual understanding. While it performed well in extracting fields without training and allowed for that hyper-specific prompt engineering, it didn't meet other criteria, as you can see on the screen. For example, it lacked that critical user interface or review station. Going back to that accuracy, the accuracy was compromised due to partial segment splits across multiple pages. And as GPT-4 is not a customizable model, we couldn't tell it that, for example, a preamble segment was on page 34 and 35 of the pages it had already processed. Additionally, due to that PNG requirement, the need to convert PDFs to PNGs for the model to process the data was a significant drawback, as we primarily received PDF documents from the business.
GPT-4 Vision does have kind of a combined, let's call it IDP OCR functionality with GPT-4's LLM functionality. The limitation of there that Anna was hitting on is that it can only process image files. It can't process PDFs directly. So we had to build a capability to do that conversion and parse things out. It also can only handle up to 10 images at one time. Now you can imagine how that becomes difficult to stitch all of that information together and give it broader context across all of the pages of the document. If something were to stretch between page 9 and page 12, the second prompt, the second time it's going in, doesn't understand the context of the first one that went in. So you need to find ways to work around that.
And speaking of ways to work around that, to create the most powerful solution, we decided to leverage the strengths of both Abby and GPT-4. There you go. We upgraded from GPT-4 Vision, which processed those image files, to GPT-4, which directly processes text extracted from PDFs, which helped streamline our workflow as we no longer needed to convert the PDFs over to an image file. Abby was then used to extract the full segment of text from the documents, and we developed specific prompts for each segment to send to OpenAI to accurately extract those required fields. There are around 100, as Josh called out, and normalize those values. And by normalize, I mean, for example, converting periods of time listed in years to months, standardizing date formats, or performing calculations based off of context in the segment. You can see the results of this combination on the screen. The result was a highly accurate solution where we went from 64 and 50% to in the 80% range, with the workstation where users could actually review those results. Overall, however, for those areas where Abby was lacking, we supplemented that with GPT-4. And overall, by combining Abby's robust capabilities with OpenAI's advanced text processing, we created a comprehensive solution that meets all of our criteria and delivers high quality results for our users. And Josh, if we want to go back to our original example, we can see what it looks like now with both of those solutions implemented.
What's very interesting in this approach is as users use that human manual validation station, human manual review station, they're actually training Abby behind the scenes. That this model ends up improving over time, whereas your feedback, your training isn't going into a GPT-4 necessarily enhancing that. It is directly enhancing Abby as a result. So over time, we can turn off fields from GPT-4 and shift those over to Abby. The users have no dual user experience of want to toggle between things. It's naturally happening in their normal review station, which is pretty cool. And to do this, only added about $600 a year costs on top of what we otherwise would have had for Abby. So drop in bucket for a huge, huge accuracy jump. Cool.
Yep. So as you're seeing on the screen, this is the original lease agreement that we were reviewing earlier. And so on the left-hand side, you're seeing how Abby was able to extract those segments. So we have the preamble, premises, and if we want to keep loading it, yeah, we have the initial term. And so Abby was able to go and pull those entire segments out as text to then be sent over to GPT-4, which you can see on the right-hand side, we were extracting fields such as the landlord and the tenant from specifically the preamble segment, or the address specifically from the premises segment. So that combined solution allowed us to leverage both Abby and GPT-4.
I'll note here too, again, we talked about the context of when we're looking at comms mining, of understanding different parts of the pros that are on the stage and be able to make sense of those. That's a big deal here because if you notice, say, rentable square feet, if you were just using something that was just IDP alone, it wouldn't necessarily be able to reconcile the fact that there's actually 3 different places in that segment where rentable square feet is called out. But here we're able to apply that logic to say, oh, well, wait, rentable square feet, the first one we're hitting is overall, the second one's for one suite, the third one's for another. Number 2 and 3 add up to make the holistic number, whereas GPT is able to differentiate that for us and disambiguate that information. And then finally, here we get to things like term dates. Now, these become particularly important in this type of approach because we would have examples where, say, the rent is increasing by 6% year over year. Well, that 6% is in a completely different segment of the agreement. It's not here right where the term dates are. So with Abby, we're able to store and parse those different segments of the agreement and then call back to them with the GPT model when we run into those scenarios where we have to do some sort of math, some sort of compounding based off of something we found earlier on, whereas that was very, very difficult to do with just a GPT, vision capability alone. You'll see one other complexity here, say in the reoccurring cost segment. So here we got the contract total. And by the way, lots of different weird ways that we've seen totals and numbers and things come out in these documents. We have to identify, in this case, the pricing is changing year to year between certain periods. We have to understand the context for what the amount is for the entire period. And we also need to then reconcile that with payment frequencies, the payment amounts, things like that, again, this is formatted completely different contract by contract, but we're able to get context in this point. So, Doug?
There was 2 questions.
Oh,
I was just to jump quickly. My question was, in the context of GPT-4, were you leveraging the OpenAI APIs or were you leveraging Microsoft Azure APIs?
Microsoft Azure. So in this case, the Azure OpenAI is what we're using. Nice thing is Abby Vantage, which is what we're using from the Abby side of things, is also hosted in Azure as well. So close calls with each other. Very, very quick response time.
Great. And then Robert had a question here. And this example is GPT-4, and I think this was the previous slide, able to discern that the first RSF value is the total, and the second 2 values are effectively a combined amount.
And the nice thing in this case, even if it wasn't natively by itself, we can run, because we're wrapping this entire thing with Blue Prism, there's additional checks that we can do in Blue Prism to fact check against what we're getting from GPT-4 as well. So we all know that GPT sometimes has some math problems. Blue Prism doesn't have those math problems. So we bounce them off of each other.
Great, thank you.
Any other questions on there?
Nope, that's all so far.
Cool. So, Doug, actually, speaking of how this is all wrapped together with Blue Prism, you want to cover that, and then we'll hop over Abby and you can show everybody what the review station looks like.
Yeah, absolutely. So when it comes to like how this solution actually works, first there's the ingestion piece, which is taking that scanned PDF and digitizing it in a text that can be then extracted downstream. As it's ingested, it's also being classified because lease documents and like many other unstructured documents can come in various different forms. So it's, and you're going to need, and the segmentation and the field extraction is all dependent on what type of document that actually is. It sets like the context for everything else, whether it's, for example, like a new lease or an amendment or, closure letter, et cetera. So that's a very important piece, is to classify what kind of document that is. And then there's the next step, which is segmentation, which is very much extracting different sections of the document so that we're not just feeding OpenAI with all of the, just every single page of the document, because that slows things down. And it also just leads to, we found less accurate results because with so much context, it actually gets confused and doesn't provide the right answer there. So we only provided the information it actually needs to understand what the term period is or what dates are. So that's where, the segments are then fed to OpenAI to do that field extraction and return that result back to Abby here, which I'll show you in what we call the manual review station, where it displays on one side the document, and on the other side, all of the, extraction. So why would that? Let's just, in the interest of time, let's hop over there, and I'm going to start sharing my screen.
We found by Doug's doing this, that segmentation piece, that ability to narrow down the focus for GPT into where the answer should be, is critical in multiple different approaches that we tested here. So again, we didn't just go about this one different way to land here, but across the board ended up being quite valuable. So even if you're not using this exact tool set, something to take away from the Gen AI side of things.
Yeah. So in this case, we go to the try and fill, and we're just uploading our lease document into our model here. We click review, upload. And then we can see for this lease document, all of not only the segments that I was able to extract, which were shown on the deck earlier, but then it's also giving us the GPT results. So pretty much anything with an underscore here is a GPT result. So it's able to say, okay, yep, found the landlord is the, like these are the easy fields, I would say. But if we go to something complicated like the recurring cost segment here, so like what Josh was showing earlier, it's able to provide us the structured amount and delineate them by semicolon here, so that if we need to put them into a database in a tabular form, we're able to easily do that using the RPA tool downstream. This is something that it would be impossible if you were just using, machine learning alone to get it to just provide you it in this format. I mean, we all know historically extracting table values has been challenging, but this is exactly the solution we needed to be able to extract all that information quickly, and also, a way to structure it and can be populated in a database quite easily. When Josh was talking about the retraining aspect of it, if we realize that Abby misidentified a segment, like maybe it left out a paragraph of recurring costs, it's very simple to just, drag that down. We'll add the additional paragraph. We find that just making sure the segments are correct is actually the most important thing. GPT does very well as long as the segment was right. So that's where we would recommend that downstream users spend most of their time, is just validating that the segment was correct. And then to the extent that some of the GPT results were incorrect, you can simply say, okay, maybe instead of a 5, it should have been a 6 there. It's just a simple user update and finalization there.
You can also drag and drop over that. And obviously, while that's not going in and saving back to GPT, it is saving it into Abby's machine learning model. So you can start to use that over time. So.
Yeah, exactly. Things like landlord and tenant, we'd expect to be able to drop as you're able to train it on more samples from the GPT reliance.
Critical thing here as well is, while we're showing, leases in this example, anything that has its, a contract type of document like this, where it's long form, but you can discern some pattern of sections, non-disclosure agreements. Most contracts have similar patterns throughout them. If you look at the same type of contract, if you can do that grouping, this same approach will work for plenty of different documents out there. We're basically trying to take a document that otherwise would be completely unstructured and group it in a way that at least getting down to the sections adds some structure to that document. Thanks, Doug. We'll pop over to any Q&A here. I'll just screen share. I got a couple takeaway things that I'll pop up on the screen, but open it up to any questions that anybody has.
Hey, Josh. Especially because you guys are using Azure AI already, or the APIs rather. Have you guys considered putting a chatbot in front of this? I can just see people like, hey, what's the most, average, all these different kind of permutations that people often ask.
We did. Actually, we built 4 different approaches using a RAG model to try and do this. A couple of those would work unattended behind the scenes, and a couple of them would allow you to ask questions about the documents. What we found is, if you wanted to ask questions in a chatbot RAG sort of model of, what's my average lease term? What's the average rent for something in this area? It does very well at those kind of broad questions where it's looking across a lot of different documents. I found that it struggled to get very precise information out of, say, a single document, taking that approach on there. So, but yeah, that definitely, that was one of our first ways of going about this.
Cassidy's got a question here. Unstructured processes will create unstructured data. Ultimately, if you're trying to generate AI for an email application with predictive and analysis in nature, then email's structure may be also simplified. For users, can be extremely poetic, LOL, and different together with lengthy expressions. Will be extremely hard to analyze and structure. Provide users with structured data features for attachment and download or upload that simplified forms, which users can create for yes or no or simplified answers. So this enabling users feature will solve a lot of AI headaches as CS training or start training people to use emails more properly after enabling those features.
If you can templatize things, provide users with structured ways to input data, that's always preferred. Recognizing that you won't always be able to do that and you can't always control the structure of your input data. This is kind of the next best approach.
I know, Jesse, you've had the health system even challenges with that. Getting clinicians to fill forms in a standard way across the organization ends up being difficult and causing extraction issues.
I can see so many applications in AHS. We have, I think, 14,000 different forms. And so having a tool that can actually ingest this type of data across the board has some use cases, legal and, like you mentioned, research and policies. Have you guys thought of any other use cases?
I guess 4 kind of main patterns of use cases that we've seen come up over and over again. I mean, they fall into, you've seen 2 of the categories that we could address here. Ends up being using GPT or an LLM to organize a tabular data. So we've had several deployments where in the middle of a document or just even as attachment, somebody sends in things that are in particular rows and columns that make sense to them, but you need them standardized before you could put them down into a downstream system. And we've used LLMs to go and rearrange those rows and columns and get them into a standardized format. The other one is looking at free text within a field that maybe you need to match to a target, a different system. So for example, you've issued a purchase order that is kind of a blanket purchase order for lots of parts that will get fulfilled over time. And ideally, you want the invoice to come back with the part number on there so you can say, okay, this part number matches to this line on the purchase order and deduct accordingly. But a lot of times that doesn't happen. So then we end up narrowing down to only being left to something that's like in the description of the line on the invoice and matching that to the description of the line on the purchase order. And usually those are not perfect carbon copies to each other. And so using an LLM in the middle there to help go and identify which line should be matched on the PO to the line item. We've definitely done that type of stuff. So there's more use cases there, but they all they a lot of times tend to fall into kind of those 4 broad categories. So
Rennie's got a question here. How well does UiPath communications binding perform in terms of understanding historical context of emails? For example, you did an address change via an email, and then a second email that's providing some missing information. Can the tool stitch all that together into a full stack response?
That's a very good question. Right now, communications mining only looks at, I think it's email body, sender domain, and subject to extract data. So it would not look at the historical chains. What you could do though is address that in post-processing. So you could say, hey, this looks like a name change request, but I can't find the information. Let's first scan all the prior emails in the thread for that information, and then, conclude we can or cannot find it. So it wouldn't do it natively, but you would do it in your automated process downstream. And you certainly could build some logic around that.
good question. We're just at time here. One thing to maybe on it, building, say, what we've done with Abby and GPT, a lot of time and energy, not only finding out and landing on what the right, most accurate solution is, but there's a lot of skill sets that were involved in putting that together. What type of skill sets would people need to have on their team to be able to create something like that?
Great question. You'd need some sort of coding background, specifically in C# and Python. C# was for the custom code blocks within Blue Prism, and Python was how we actually tested our prompts. You'd also need some sort of RPA process background and prompt engineering experience.
And I think on the prompt engineering things to round things home is across all of these, you cannot overstress the importance of business users involved with this. You have to have people that are subject matter experts that are going through, tagging things up, giving context to what is the right answer, what's not, reviewing results. If you don't have that and you try and make this just a technology challenge, you're not going to get very far in it. So don't forget, the biggest bulk of the work on here is really with working with business teams to train these things up. So appreciate Jesse hosting us and everybody that's stuck around throughout the session. If you want to hear more, Aaron mentioned a few other things that we're doing on the comms mining on downstream on the automation side of things. If you want to check out some more detail about what we're doing in the IDP plus Gen AI space, reach out. Love to chat with you.
Hey, what's the best way to contact you guys, Josh?
That's a good question. I can, Jesse, are you sending a follow-up email with the recording? So here,
Sure can.
I'll put it in my contact or my email, at least in the chat here. And then just can share that.
LinkedIn is another approach if anyone wants to contact you guys.
Yep.
Yeah.
Josh Noble on LinkedIn. Look me up there, but yeah, love to chat.
Sounds good. All right. Yeah. So I'm just looking at your chat message, josh.noble@revealgroup.com. Perfect. Well, thanks so much, Josh, Doug, Aaron, Aiden. Amazing stories and definitely inspiring. Look forward to having you guys back whenever you're ready. And thanks everyone for joining us. Thanks so much.
Appreciate it.